Welcome once again to the Learning Java with Dr. Piercy series. This is the second session of our Java Review series. In this session we will briefly review a previous example, we'll review how to create Java methods, and we'll use those Java methods to complete a program. It's always a good idea to think before programming. As I often say, you can never write a program to solve a problem unless you fully understand that problem itself. So let's think about averaging or calculating an average, giving a list of numbers. The first step would be to get the list of numbers. For example, we might get an array of numbers. Next, we need to add the numbers to get a sum. So if we add up this list, we would sum them up to be equal to 35. Next, we could count the numbers to get the count of how many there are. In this case, we have 7 in our array called numbers. As you may realize, 2 and 3 could be interchanged. We could count the numbers, then add them up. It makes no difference. However, they both have to be completed before we go on to step 4, where we divide the sum by the count to get our average. And then we would probably need to output the results so somebody can see what the average is that we were trying to calculate. Now that we've thought about what we're going to create, let's review what we did last time when we created a class called Average Controller. You can see Average Controller in my Eclipse view on my desktop. You notice that the project is called Average. In source, I include a package called myPackage, and within that package I have stored a Java class called Average Controller. Let's have a look at what we're doing inside of Average Controller. Last time we discussed public static void main. This is the method that all Java programs look for to begin with when you ask to execute the program. You can think of it as the main controller for any Java application. When main is executed, we first initialize a few variables, a variable to hold our sum and a variable to hold our count. And for our simple example, we just created an array of numbers we called numbers and typed that in. This is how you might declare a constant array. It's good for quick, simple arrays. Then within our main class, we followed the steps that we talked about when we were thinking before programming. We used a for loop to add the numbers in the array. Next, we use another for loop to count the numbers in the array. Then we calculate an average by dividing the sum by the count. And then finally, we're outputting the results. This time they're going to go to the Eclipse console, where we can simply read what the sum, the count, and the average is for our array. To see that in action, let's make our console area slightly larger so we can see the results. And let's run our program in Eclipse. A couple ways you can do that. My preferred way is generally to right-click on the project and do Run as Java Application. And you can see that the numbers 5, 1, 9, 0, 10, 3, and 7 add up to 35. Add it up yourself and you should see that's the result. There are 7 of them. And then 35 divided by 7 gives us the average of 5. To summarize, last time our review we talked about what the main method was. We talked about variables and different data types. We talked a little bit about arrays and how to work with arrays. We discussed for loops. We reviewed a little bit of math, and we talked about how to output our values. To motivate what we're going to talk about in our next example, as we add some code or alter the code in this example, let's think about what would happen if we added 2 new arrays. As you can see here, I have added 2 arrays and I have renumbered the first one to reflect that I now have 3 arrays instead of 2. If I wanted to do the same thing, calculate the sum, count, and average for all three of these arrays, one strategy would be simply to recopy all the code that does the work and then edit it. Let's see, for my second set, I will need to make sure that my sum has been reset to 0. I am now using the second array. Make sure that count has been reset to 0. Also use the second array here to make sure I can see where the new one begins in my output. Let's just put a simple line of asterisks. That should take care of the second one. Now to take care of the third one, I can simply copy that, paste it, and change the array to reflect the fact that this time we were doing numbers in the third set. Let's clear our console so we can see the difference in our results and run the program again. Notice we have a sum of 7, average of 5, sum of 42, an average of 6, and now a sum of 16 with an average of 3. There's a problem here. This strategy makes for a very, very long program if I want to do this for many more arrays. Notice we had to copy and paste roughly 15 lines of code over and over again for every new array. Turns out there's a better way, and that way involves methods. So what is a Java method? Formally, a method is an operation that can occur with a specific Java object. When we create classes, a method is one of the types of members of a class. The other type is a field which will hold the object's state. We will talk more about that in our next review session. Informally, a method is a way to move code to a callable section. This means that we can ask in one part of our code to run the code that is in the method. This is called calling the method. When we call the method, we need to hand the method important data that is needed for the method to do its work. We might need to give the method some input. These are called parameters or arguments. We'll make a distinction on when we call these parameters and when we call arguments. Basically, when we're creating the code for the method, we'll discuss them as parameters, and when we're calling the method, we'll call them arguments. After the method runs, there may be something created. The data is processed to create a value, and so we need to receive the results. This is called the method's return value. Let's look at Java methods in depth. Here we see the general syntax that we will use when we define a method within a Java class. We can start with an optional access modifier. The access modifier determines what other classes can see and make use of this method. Where can it be called from? This is followed by the return type. The return type specifies the data type, the output data that this method will return. What's the result of running this method? Well, this is the data type of that result. The return type is followed by the method name. The method name generally starts with a verb and may include some nouns and will somehow describe what the method is going to do. We'll talk more about the naming of the method in a little while, but suffice it to say the designer of the program can basically choose what this is. Many methods will also need inputs. These are provided as a list of parameters. For each parameter, we'll include a data type and the name of that parameter. So basically, the method will take these inputs in, will do some things and then create something. The thing it creates by starting with this parameters will be the output and will be of the type that is specified as method's return type. Within the method, we'll put different code for it to actually execute the behavior that we want. This behavior may create something, so we'll need to be able to include a return statement. So in this example, in this general syntax, we're including a declaration of a variable that is of the return type. We're showing with a comment where we might put code to actually do the work of the method. And here we see a return statement. If your method is actually returning something of the return type, you must have a return statement, and it returns the output value of the particular data type. Let's look at an example. Here we see an example method called addNumbers. Basically, this method is designed to take in two numbers as input, add them together, and return them as output. We can see that all the numbers that we're dealing with in this method are of the data type integer. The access modifier is public. This means that this method is available to anything that has access to the class that contains this method. The return type is int. This means that whatever is created by the method will be of the integer data type. It will be an integer number. The method name is addNumbers. Notice how we've used camel case. Starts with a verb and then is followed by another word representing what the verb acts upon. This method has two parameters. Both of them are of type int. The first parameter is the first number, called num1, and the second parameter is called num2. These are actually variable declarations that are local to this method. This means that num1 and num2, as soon as the method is called, can be used as variables within the code of the method. In the code itself, we see that we first declare a variable to hold the sum of the two numbers, and we call it sum. We then have one statement that simply adds the two input values and assigns the result to the new variable called sum. And then we have the required return statement that returns the sum. As sum was declared as an int, it matches the return type of the method, which was also int. Access modifiers. 4 basic access modifiers. These are private. This means that the method is only available for code within the class itself. We also have protected. This means that it's available to classes in the same package or any subclass. A protected method is not available to classes that are not in the same package. Default. This means we leave off the access modifier altogether. We don't put one. This is similar to protected. It's available to classes that are in the same package. The main difference is that protected allows us to have inheritance where the subclass can be in a different package. With default, it's only classes that are in the same package that can access the method. And finally, we have public methods. Public methods are available to anything that have access to the class itself. Highlighted private and public as these are the two most common access modifiers that you'll come across and use. Java methods also have return data types. With one exception, these are basically the same as any data type we can use on a variable or object. The one exception is listed here is void. If void is used as the return type, the method does not return anything. We can also, of course, use primitive data types such as int, double, etc. This means the method will return a value that is of the primitive data type. Or we could return an object. This could be any class that's available for us to use, and the method will return an instance of the specified object. Here are some other miscellaneous rules that we need to remember when defining our methods. The method name with the parameter types is known as the method signature. Basically, everything that defines the method except for the code inside of the braces is part of the signature. This can be important because this also defines how we interface or interact with the method itself. By convention, method name should be a verb in lowercase, or a multi-word name that begins with a verb in lowercase, followed by adjective, nouns, etc. In the multi-word names, the first letter of each of second and following words should be capitalized. This follows what we call camel case convention. You can have more than one method of the same name within a class as long as they each have a different parameter list. This is called overloading. By different parameter list, this means that the signature will be different enough so that the Java compiler can tell the difference between which method you're calling. Let's look at how we can make our average program more useful by moving some of the work to methods within the same class. Notice for every average we had about 4 steps. We would sum the numbers, count the numbers, calculate the average, and then output the results. It would be nice if we can create 4 different methods that every time we need to do something, we simply call those methods instead of calling all of the code here. We'll start by creating a method we'll call getSum. We start by determining what access modifier we should use. Let's make this one public, which means any class that has access to our average controller class should be able to see and use this method. We follow that by putting in the return type. Since we are going to deal with all integers, the sum of our list will also be int. We then have to give our method a name. Let's simply call it getSum. The verb is to get, and the result is the sum. Makes perfect sense, and it follows the naming convention. Next, within parentheses, we need to include any parameters if needed. In this case, it would be nice just to pass our whole array to getSum, and that it should be able to do the work to add up the numbers. So let's do that. Let's say that the parameter is an array of integers, and we'll just call those numbers. Now the name of this variable is local to this method. So this numbers that we have declared here has nothing to do with the numbers that is currently used up here, except for that at some point we may hand these numbers to the method, and at that point it will call them numbers. But this is a local name. It only refers to the numbers while this particular method is running. More on that later. Notice we currently have an error message with this particular method. Recall that if we include a data type in our method signature, that we must include a return. If we call, say, void, this would be one way to clear up the error message, because void means it does not return anything, so it does not require a return statement. But if we include a data type, we must have a return statement within our method. So this error message serves as a reminder not to forget to put the return statement. Notice I could choose that from the list, but we'll start by, let's declare a variable called int, which is of the data type that we're going to return, and give it a name, and let's set it to 0 just to declare and to instantiate the sum variable. We know whatever we do to create the sum, we're eventually going to return it. So as long as we go ahead and declare and then return our sum, we can get rid of the error message. So in between here, all we have to do is add the numbers in the past array to get the sum. So how can we do it? A number of ways. One way we already did up here. We had a for loop. Basically, we can copy that and paste that in. And since the numbers is the same as what we've called it here, this code should work fine. Remember, this works with the local variable called numbers, not the same numbers that is up here. Let's save what we have, and let's test a little bit. So now that we have the method, we no longer have to calculate the numbers here. So we're still going to need to add the numbers, meaning we have to run the method, but we're going to do it in a different way. Let's briefly think about what we refer to as calling a method. Calling a method basically means asking to run the method and passing it any input values it needs as arguments, and then receiving the return value and storing it locally as whatever data type the method should return. So the syntax for calling a Java method appears here. This is a general assignment statement. With an assignment statement, the items that are on the left are evaluated first and then assigned to whatever is on the right of the equality sign. Notice we have the return type. This should match the return type of the method that we are going to call. In this assignment statement, we're declaring a local variable or object that is of the return type. This is what's going to hold on to the results of the method call. On the right side of the equal, we have the expression that's going to be evaluated and then assigned to that local object. Here, we use the object name. Recall, most of the time we're calling a method, the method may be part of an object that we have a handle on, may not be part of the class that we are currently working in. So we use what we call dot notation and name the object that we have declared first that has the method. The method is a member of that object, followed by a dot, and then the method name. Basically, we're saying, please run the method for the object specified here. We can't forget that the method that we're calling may need some input values, and these are going to be passed as arguments. Generally, these are values that we know or will hard code in as a list separated by commas that correspond in data type and order to the parameters that we defined in the method. For example, we might have an object we've declared and instantiated called summing class that has a method called addNumbers. In this case, we're using the summing class dot add numbers to say, please run the method of the summing class that will add the two numbers. In the parentheses, we pass a 5 and a 12 as the arguments that will be added. When these arguments are added, to make 17 of course, that will then be assigned to a local variable called sum. Let's see how we might put that to action in our particular program. Notice our method is called getSum. We need to have a local variable to put that in. You might note that we'd already declared that variable, so we simply need to use the variable in this line. So we're going to get the sum and we're going to apply it here. Now the object name, in this case, we need an object to use that. Trust me when I say that because main is static, in order to use a non-static method, even if it's in the same class, we need an instance of the average controller class in order to call the getSum method. So let's declare one of those here. To do that, we would do average controller. Let's just call it AC for short, equals new, and we'll call a default constructor to create it. Now our average controller has a getSum method, so sum equal AC dot, that's our object name. Notice when I hit the dot, a list of all its methods comes up. GetSum is one. There are many others. These are inherited from the general Java object, which everything is a subclass of. I'm going to choose getSum. And then for its argument, Notice down here in our method we said we will supply an array of integer numbers. We have one called numbers here that is supplied or created already, so let's just use that. I'll end it with a semicolon, and now we're good to go. What happens if we run? Now, even though our loop has been moved to a method, we still get the same sum, count, and average that we originally did with our original numbers array. This time, though, instead of performing the loop here, we are performing it in another location. So in a sense, when this method is called, program control moves down to the method to start running the code there. The array that was called numbers in the calling area was passed to the method as an integer array. At this point, we have a copy that is a local variable called numbers array. We sum that up, and what we hand back or return is a sum which is data type int. So when the sum is calculated, it's kind of handed back to the calling and then assigned to the local variable there called sum. Let's quickly create some more methods to handle the next 4 steps, and then we'll see how that can be useful in handling our original quandary with several arrays. So let's create a separate method for handling the count. Start with our access modifier. In this case, we'll stick with public. The count will also be int. getCount seems to be a reasonable name. This will also take, anytime we call it, we want to hand it an array of integers, and locally we'll call that numbers. We see that there's an error message, so we should always pause to see what it is, but this time we see that it's simply a reminder that we need to include a return statement. So let's go ahead and make sure that's taken care of. We'll have a local variable called count that we'll set to 0, and we're going to return count. Of course, we want to do some things in between. This time, rather than using a loop, which we did it last time mainly for the sake of reviewing loops, let's do this an easier way. Any array has a variable value known as its length. The length of array is pretty much a count of the items that are in that array. So the count is equal to the numbers.length. Logically, you might ask, why don't we just set that to the count up here in our main? And you, of course, be correct, we could do that. But then we would also lose the advantage of playing around and learning how to use methods with some simple methods. Now that we no longer need to loop and count the numbers here, we can put a simple statement that calls our method. Notice it now shows up when we hit dot. And now we have a count. I'm generally old school. I like to write a few lines of code and then test frequently. Then I can move forward with confidence. So let's run this again to see if we still get the same sum, count, and average. Yes, we expected 35, 7, and 5, and we're still getting those. Now our methods are doing the sum and count. Let's turn our attention to calculating this average. There'll be some key difference in this method than others. First, to calculate an average, we need 2 numbers. So we're going to have to pass 2 arguments to the method. Second, the return type will be different. Notice the average is double. So we need to create a method that returns a double. Simple enough. Let's move here. Keep it as public. Double get average. We need to hand in the sum and hand it the count for it to do its work. Again, we see the error that we need to have some type of return. So let's create a double, matches the return type. Let's call it average. Let's instantiate it to 0, just so it'll always return some number. And let's do our return of our average variable. Then we can do a calculation. Average is equal to our sum divided by our count. Let's call this, and then let's clear our console. Let's change this to a call to the average. And then let's test again. Test often, move forward with confidence. Still getting our average that we expect. One thing you might notice is that I'm intentionally being verbose when I write my code. You might also say I'm being verbose when I'm explaining the code too, but you can always use the fast forward if you don't like that part. What I mean by verbose with this code is that I could actually have done this particular method with 1 line, much like I could have done the getCount with 1 line. For instance, this method could easily have been completed with just the single line, return the sum divided by the count. As you've seen the other, I'll just leave this one. I'll run it again, and I see I still get the sum. Similarly, I could have just returned numbers.linked for that method. You may say, what's the use in writing methods that are this short? The idea is it's actually good design to write methods that do one thing and only one thing very well. In our average controller, we basically have the 4 steps going to 3 of the 4 steps going to methods. Let's create another method for the output. Notice in this case, we really don't want to return anything to the calling method or the main. So, one difference in this particular method is that we'll use void. We'll call this one printResults. And let's say we pass it an int for the sum, an int for the count, and a double for the average. So you can see 2 major differences in this method and the others. One is that we have 3 varying data types for our parameters. Notice the order. If we were to call this and put the double first in our calling statement, we would have a problem. We must give it int, and double. Second, the return data type is void. This means nothing goes back to the main method. However, something will happen. We'll see the results in the console. So to save ourselves a little bit of time, let's go up here and get the actual code, which should correspond to our current variables. Since we may call this several times, let's add a little bit just to make sure we can differentiate between our different output. I'm simply going to include a line of asterisk here so we know each time that we call it. We'll start with a new set of numbers. We'll save that. And then up here where we wanted to see the results, we will do AC dot print results. And we need to give it our sum, count, and average. You'll notice another difference here in calling this print results method. What you should notice is there's nothing on the left side of an equal sign, and there's no equal sign. Since print results returns nothing, it's a void data type, there's nothing that comes back that we need to hold on to. So we simply just call the method. Basically we say, please print the results. No need to hand anything back. Let's test. With the exception of a set of asterisks, we're getting the same results. So how did this help us? Well, for one thing, you learned how to do methods, but the main idea was, what if we have multiple arrays? I'll create a second array called 2. I'm going to try to set this one where the average will be 4. So if I have 1 and 7, that should give me a 4, a 3, and a 5, and a 5, 6, and a 2. Let's even have a third array. Let's say this one is simply, give me an average of 3. We'll go 1 and 5 and 2 and 4. Slightly different count. This one has 5, the others have 7. So how can we call this? Well, basically, we recall the methods. But instead of repeating 15 lines of code, we're repeating 4 lines of code each time. Notice I have to adjust a little bit to make numbers 2 and numbers 3 arrays. We see 3 sets of sums and averages and counts. One other thing to note, remember the naming conventions and the local variables. Here we had one array called numbers. When we call getSum, we pass it the local thing called numbers, which is currently 5, 1, 9, etc. When getSum is called, it takes whatever array it's handed, and locally it decides to call that particular array numbers. It's coincidental that the array it was handed was also called numbers up in the main. So locally what it's referring to as numbers is sum equals 0, and it adds it up and returns the sum. The next time that sum is called in main, we're handling it something different called numbers2. Totally different name. Sum says, well, you know, I don't care what you call it. While I'm working with it, I'm going to call it numbers, and it uses it, calculates a value. It returns that value back. as the new sum. So you have to kind of keep track of what is the name locally versus what is the name locally in another method. This numbers is a local array for this particular method. When execution goes back to main, it can call the result or the input anything it wants, and that can be completely different. In this session, we reviewed a program we made in a previous review session to calculate an average. We thought before programming. Important step before creating any program so we thoroughly understand the problem that we're going to program. We improved our average program by moving some of the code into methods, all within the same class at this point. And we adjusted our main method to call and use these methods. This has been a Piercy production. Copyright 2012. All rights reserved.